Um, we are no longer in trig with chapter 1, okay? We're going back to chapter 1, okay? In here we talk about functions. You can go there. We talk about functions, and we're going to learn really how it is that these functions function, okay? And we're going to have to do a lot of things without the calculator because we really have to understand the way these functions think. Okay, so first, a little bit of a review more formally about this interval notation so that, I know we've been used to it a little bit, so that once and for all, we get this. So this chart tells you, it compares the inequality written in set notation and then in interval notation. So the second column, this column, and this column is how we do it, starting with pre-calculus and definitely in calculus and moving onwards, right? So let's do a couple of these here. So for A, it's going from -2 to 12. So we just say -2 to 12. And if they're closed on both sides, then we put brackets for closed, right? So the summary basically is if it's less than or equal to, it looks like that, right? If it's less than, it looks like that. Okay? All right. So here, x is greater than -17. That means it's all the numbers from -17 and onwards. So everything starting from -17 all the way to positive infinity. Because this is open, it's a parenthesis. Infinity always gets a parenthesis because I never know where infinity is. It is not a discrete point. So I can't say it's a point to be included. Okay? All right, here, x is less than 3 or x is greater than or equal to -8. So let's do the first one first. This, it's 3, it's negative infinity all the way to 3. Open. And then I'll talk about the or in a minute. X is greater than or equal to 8. It's all the numbers starting from 8 and going to positive infinity. In between, we put the symbol, which means it's union. Okay? Yeah, it's a union. Now, so it's not like it's not a U like this that comes back down, right? It's just just like that. Okay. Talking about negative infinity to 3 for a minute. When we do interval notation, it always has to be the smaller value to the larger value. So we don't do this, right? That's out of order. Okay? So that's not allowed. It always goes from the lower value to the higher value. X is less than 0, negative infinity to 0. Okay? All right. What is a function? A function is a set of ordered pairs in which no two different pairs have the same x value. So for example, if I look at it on the coordinate plane, I can't have the same x value belong to two different ordered pairs. So for example, if x is 2, I cannot have 2, 3 and let's say 2, -2, right? That is not a function. All right? So each x can only have one y value. That's how I define a function. So if you see here, each x can only have one y value. So if x equals 2, the y value can only be 3. It can't be 3 and -2.
But can't two y values have the same x?
No. Two y values can have the same x. No. Two x values can have the same y. Yeah. All right. The best way to think about it is the vertical line test, which means if you can draw a series of vertical lines through something, and if each vertical line passes the graph one time, then it's a function. All right? So if you have something like this, right, where a vertical line would cross twice, it fails. Yeah, it's not a function. Okay, so you can have functions represented, or relations rather. Anything can be a relation. But if a relation passes the vertical line test, then it's a function. You can have relations represented in a whole bunch of ways, as coordinates in a chart, the graph, the function, right? And so let's go through each type and see how we can determine whether or not something is a function. So this first one here, so look at the x values. They're all different, which is good. Okay? So yes, this is a function. All right? Now, how about this one? Look at the x values. Okay, so look here. You have two x values, and now you have to go to the second phase. Do they have the same y values? No. So this is not a function. Okay, so suppose the first one is 0, right? Suppose this was also 0. Would it be a function now? Yeah, it would. You've just written it twice, right? But the way it is, it's not a function. What about the C? Is it a function?
Yeah.
It passes the vertical line test.
Okay, you should draw like the vertical line.
That's a horizontal line. Vertical line. Vertical line. So yes. Okay. Here, x equals 2y squared. Okay, so let's think about this one for a minute. Suppose you had a value for x. Give me a value for x. Pick a number, any number. 2. Okay, so suppose x is equal to 2. Now, this function, right, when I plug in the 2, it would look like this. Let's solve this for y, because why not? 1 equals y squared. Take a square root, take a square root. Y is how much? Plus or minus 1. So what does this tell you? When x equals 2, y is plus 1 and negative 1. That means at x equals 2, I have 2 coordinates. So is it a function? Not a function. Okay? So not a function. Okay? One x value produces 2 y values. So it's not a function. And you can kind of tell, well, not kind of, you can tell, this is math, there is no kind of, right? You can tell because it's y squared to a single x. So if you solve this for x, automatically you're going to get plus or minus for the y. All right? So you can tell, you can say that, you can tell from that. If it's the square of y to a single x, it's not a function. Okay?
So there can't be 2 x's. 1 y.
One x can't have 2 y's. Think of it like this.
Right, no, I know.
One x, yeah, can't have 2 y's.
I know how it looks. I was trying to get like a word.
Yeah, one x cannot have 2 different y values. All right. All right, so function notation. I know you know this from algebra 2, but basically f of x is function notation. It is the same as what we always, used to call y, right? The thing about f of x is it tells you two pieces of information. It tells you the name of the function, f, and then it tells you what variable is used in the function, right? So f of x, this is the name of the function. And then this is the variable in the function. It's actually the independent variable. Okay? I can have v of t, and what's the name of the function? V, and the variable used in the function, t. Okay, so f of x, remember this, is the y value. Okay? X is any value in the domain, and it's the independent variable. Y is the values in the range, and it's the dependent variable. All right? Okay. Yes. All right. So, you guys remember this? Yeah? Okay, it's going to show up a lot because I need it to be solidified by the time we do chapter 12 and by the time you get to calc. Okay? So, we're going to do the same thing. We're going to do f of a plus h minus f of a over h. Okay? So, this is f of x. Okay? What's f of a? A squared minus 2a. So the x just gets replaced with a. So what else do I need? I need f of a plus h. So what's f of a plus h? Now the x gets replaced with a plus h. So a plus h squared minus 2a plus h. Okay?
Over h squared.
Huh?
It'll be over h squared minus 2h.
No,
it's not f of h. How do we know that f of x is a squared minus 2x?
Oh, you're given that. F of x is x squared minus 2x because you're given that.
Where?
This will be given, you're given this.
Right, so how do we know that f of a? Oh, that's just a different variable. Oh, no, sorry.
We all have these moments, okay? So, this is a squared. Okay, I'm going to multiply the a plus h squared. A squared plus 2ah plus h squared minus 2a minus 2h. Okay? Now, so what I'm looking for is, first, I needed f of a, which I already found. It's right there. And then I need this. So f of a plus h minus f of a over h is equal to f of a squared minus 2a. Oh, no, sorry. F of a plus h. I'm looking for this now. F of a plus h minus f of a over h, right? So, what's f of a plus h? It's the blue. A squared plus 2ah plus h squared minus 2a minus 2h minus f of a. So what was f of a? A squared minus 2a all over h. And then, if you're lucky, some things cancel. So let's see. A squared plus 2ah plus h squared minus 2a minus 2h. I'm going to distribute the negative, minus a squared plus 2a all over h. Okay, this is my favorite part. A squared minus a squared. Negative 2a positive 2a, what do I have left?
2ax plus h squared minus 2
Yes. What can I factor out of the top?
How did you get 2AH squared?
I didn't. 2ah plus h squared. I can factor out an h, and I get 2a plus h minus 2 all over h. Now what? You cancel out the h's, and I'm left with 2a plus h minus 2. Okay? Okay. All right, so let's do another one. This time my function f of x is equal to 3. What does that look like? What does that function look like if I draw the function? Is it like that, or is it like that? Okay, what's another word for f of x? Y equals 3.
Goes to the right.
So it's horizontal. No matter what x is, y equals 3. When x is 1, y equals 3. When x is 5, y equals 3. Okay, so now what I want to find here is f of a plus h minus f of a over h is what I need to find. So that's my function, y equals 3, f of x equals 3. What's f of 0? What's the value of the function when x is 0? When x is 0, how much is y? 3. What's f of 2? When x is 2, how much is y? 3. What's f of a million? 3. What's f of negative 3? 3. F of x is always 3. So f of a is how much? 3. F of a plus h is how much? It's just 3. No matter what the x value is, it's 3. Okay? So what's f of a million? 3. F of a, 3. F of b, 3. F of a plus h, 3. F of table, still 3. Okay? So that means this is 3 minus 3 over h. 0 over h is 0. Okay, question. Yes. Did you have a question? Aiden, did you have a question?
No.
Oh.
I did, but
Okay. So let's talk about domain. When you have a function, just a random function, f of x equals 3x squared, and they don't tell you the domain of the function is specifically this, then there is an implied domain. The implied domain is the set of all real numbers for which the expression is real. Okay, that means it's all of those numbers that when you plug it into the function give you a real value. Okay? Now, a lot of times, right, it's like, okay, it's like when somebody asks me, hey, what do you like in math? I say, well, it's easier if I tell you what I don't like in math because, right, that's a smaller amount of stuff. So for the domain, it's easier sometimes to just say, where does this function not exist, right? And just exclude those points and say, okay, the domain is all of the points except for those two that I just mentioned, all right? So what we do is we exclude the values from the domain that would result in division by 0 or taking the root of a negative number. So you ask yourself, where is this function undefined? When would I divide by 0? Where is this function going to give me an imaginary number? All right, so look at some examples here. Look at the first one. What's the first thing you notice? What's an error? What's a problem of what?
you could factor it.
that at -2, the problem is that at -2, the denominator would be 0, and then you would be dividing by 0. So it doesn't work at -2, right? So that means this tells you that x cannot be -2. So then what's the domain? If I have a number line, this is 0 and this is -2, my function can work everywhere except for -2. So to write the domain, I say, okay, it works from -infinity to -2 and from -2 to infinity. And the way I write it is this, the parentheses just went away. -infinity to -2 and from -2 to infinity. Okay? All right, what about this one? What's the problem with the square root? You can't have a what inside? A negative. Can you have a 0 inside? You can have a 0 inside. You just can't have a negative inside. So the way we do it is, okay, this has to be a positive number. X minus 2 has to be 0. I'm sorry, has to be greater than or equal to 0. So x has to be greater than or equal to 2. In function notation, that's 2 to infinity. Bracket, sorry. The bracket went away too. Okay. All right, so let's do some domains. The problem, we're going to take different functions. We're going to take the functions with different classes at a time. So first, we're going to talk about polynomial functions. These are the best types of functions because their domain is always all real numbers. Okay? What's a polynomial function? Basically, you have to have the variable raised to an exponent, which is a whole number. So either 0 or above. Okay, so variables have whole number exponents. Right? That means 0, 1, 2, 3, 4. No fractions, no negatives. Okay, this is a polynomial function for part A. The domain is all real numbers. This is another polynomial function. What's the domain? All real numbers. Okay. We run into problems with rational functions. Basically, the domain for this is every number except for the zeros of the denominator. Okay? So first, find the zeros of the denominator and exclude them. Okay? So check where the denominator is equal to 0. Most of the time you have to factor. All right, so let's factor this first guy. 2 over x plus 4, x minus 3. Okay, where is this 0? 3 and -4. So x can't be -4, x can't be -3. Positive 3. So if you look at the number line, at -4 and at 3, this can't exist. Okay? But it exists everywhere else. So the way we write it in interval notation is, we say -infinity to -4, union, -4 to 3, union, 3 to infinity. That's the domain. Yeah, we always go smaller to bigger. Correct. Okay, so what about this one? We factor So what can t not equal? 1 and negative 1. So it's negative infinity to negative 1, negative 1 to 1, 1 to infinity. Okay. Okay, so the next one, you have to do a common denominator, right? Think of it as a common denominator. So if you do a common denominator, what would it be? Right, that would be the common denominator, right? I don't care about the numerator really for the purposes of the domain. So where is that not gonna, at 10 and negative 8 you have issues. So we say x can't be 10 or negative 8. So what's the domain then? And then 10 to infinity. Okay, what about the next one? That's my favorite out of these four. What do you guys think? Find where the denominator is 0. It can't be. So let's see. You can't factor that, right?
And if you think it's negative 1.
Exactly. Like if you say, okay, it's got to be 0 at negative 1. No, but negative 1 squared is 1. Plus 1 is 2. So you're like, you know what? Hang on. I'm just going to set this equal to 0 and find all the points where it's 0. Okay, so let's do that. X squared equals negative 1. Take a square root. X is plus or minus the square root of negative 1. That's an I, right? Well, that means there is no real number for which the denominator is 0. If there is no fear of the denominator ever being 0, then the domain is all real numbers. Okay? Denominator is never equal to 0. You can. I'm just getting you guys used to the interval notation. It is foreign in the beginning, but by the end, you get so used to this notation. It's so lovely, you never even look back. I'm telling you. Yeah. Okay, so we did polynomial functions. We did rational functions. Let's do radical functions. Okay. Okay, so radical functions, this has nothing to do with their political views, right? They're just under a radical. So, the domain of a radical function, if it has an even nth root, is the number for which the radicand is greater than or equal to 0. So, for example, if I have a square root of x, right? What's n in here? It's 2. It's a square root. If I have a fourth root, if I have a sixth root, and so on, I have to make sure that the number inside is greater than or equal to 0. If I have an odd root, odd nth root, then the domain is all real numbers. So if you have like cube root of x, fifth root of x, that's cool. Because can I have the cube root of negative 8? Is that okay? Yeah, what's the cube root of negative 8? It's negative 2. That's totally cool. So if it's a cube root, we got no issues. If it's a square root, it's got to be 0 or higher. Okay, so here, what we do is we take the radicand, which is the stuff inside, and we set it, we say it has to be greater than or equal to 0. So I add 70, and x is greater than or equal to 10. That means the domain is 10 to infinity, and look, it's closed at 10.
What if the sign of the difference change?
It could be, and then you just go less than, right? So if it was like 70 minus 7x, then it would have to be the lower number. So it would be negative infinity to 10.
What if those x is less than?
That's what he asked.
Right, no, but I thought he asked if it's like.
So if it was, let's say, negative 7x, this would cause the sign to switch, which is cool. It would just be negative infinity to 10.
Right, but how would you write it? Oh, negative. Yeah.
Negative infinity to 10. Because it would be like the negative numbers who would come in and become positive. Okay. Oh, this next one. Okay, let's do C first. What's the domain for C? Huh? All real numbers. Okay, here we have a non-linear inequality. So here's how it's going to work. X squared minus 2x minus 15 is greater than or equal to 0. Okay, I'm going to factor this. And I'm going to get x minus 5, x plus 3. From that, I extract x equals 5, x equals 3. Now, A was a linear inequality. That's just straightforward. This is a non-linear inequality. If you have x squared, a quadratic, cubic, quartic function, when you extract the values here, negative 3 and 5, you have to put them in a number line. You did this in Algebra 2. Some students remember, many forget. You put it on a number line. Now that splits the region into the number line into 3 regions. What you're going to do now is you're going to pick points from each of the regions, and when you plug it in, see if you get a positive or a negative answer. Okay? So, if I pick a number, my favorite is 0, but let's go to the left first. Here, pick a number. Negative 4. Instead of plugging it into the original, I like to plug them into the parentheses. It's less math. So if I put negative 4 in here, right? The first parenthesis gives me a negative value. The second parenthesis gives me a negative value. Together, it's positive. I don't care about the value itself. That's why it's easier in the parentheses. Okay. If I pick a number from negative 3 to 5, my favorite is 0. I get negative and positive, and that's negative. And then from the other region, it's going to be positive. Okay, so I kind of lost sight of what I was doing, right? I'm looking for a domain. I want the values of x that are going to make the radicand positive. So I take the first and the last region. So I'm going to take this region and this region. Okay? So the first region is negative infinity to negative 3. And the second region is 5 to infinity. And it's got to be closed here because it's okay for it to be negative 3 and 5.
Why is it?
I thought it can't be negative 3 or 5.
It can, because you can have 0 underneath the radical. Okay, what about this next one? I like to rewrite this. An exponent of 3 over 2 is the square root of 9x minus 2 cubed. So this is a square root, which means the inside has to be positive or 0. So I say 9x minus 2 cubed greater than or equal to 0. I can take a cube root of both sides. 9x minus 2 greater than or equal to 0. 9x is greater than or equal to 2, so what's x? Greater than or equal to 2 over 9. How do I write my domain? 2 over 9 to infinity, closed. Okay. Okay, look at the next one. It's a radical. But where is the radical? In the denominator. So, being a radical says it's got to be 0 or above inside. But since it's downstairs, can it be 0? No. Right? So, because the radical is in the denominator, it also can't be 0. So it's not greater than or equal to, so it's just x plus 2 is just greater than 0. Okay? Can't be 0 in the denominator. So it's just x is greater than negative 2.
How come it's not negative infinity to negative 2?
Because it's the value is greater than negative 2. Yeah. Okay. How about the next one? Look at the next one. You have two problems here. What's one of the problems? The radical, right? So the radical, it has to be greater than or equal to 0. So x is greater than or equal to 3. Huh? Yeah.
So it doesn't denominators can't be 0. They can be negative numbers, right?
Correct.
So why can't x plus 2 be less than 0?
Because it's a radical. So there are two conditions here. Okay, so this tells me x is greater than or equal to 3. Okay, what does the denominator tell me? X can equal 6. Okay, let's think about this for a minute and then I'll take your question. So this is 0, this is 3. So this is telling me all of these numbers, right? Where is 6? Here. It can't be 6. So there is a cutoff there. Like there is one instant where it can't work. So you gotta do the union. So it has to go from 3 to 6, 6 to infinity. Isn't that cool? Right? Okay. It has to be greater than 0 for h, not equal to. So it's just 2x minus 3 greater than 0. So 2x is greater than 3. Divide by 2. X is greater than 3 over 2. So it's open. Okay. So, did you guys do piecewise functions last year? A little? Okay, let's do this. A piecewise function is literally a function that's broken into pieces. Okay, it's broken piecewise. So, by definition, it's defined using two or more equations for different intervals of the domain. All right? So look at this one. This is telling you that this function is split. Where is it split? The stuff on the right tells you the regions. All right? So this defines the regions. How many regions do we have? 2. One is the region where x is less than 0, so to the left. 1 is the region where x is greater than or equal to 0. Now, when I'm just getting started with piecewise functions, I like to put a little dashed line just to define my boundaries. So here there is a boundary at x equals 0. Eventually, when we get used to this, we'll let go of that helper. Okay, now these are what to graph. So if this is what to graph, then the red was where to graph them. Okay? So now, on the left, when x is less than or equal to 0, I'm going to graph negative x plus 2. On the right, I'm going to graph x squared plus 2. Okay? Now, the first thing I must do, I cannot get away with not doing this, is plot the point on the boundary. Okay? So, for the top function here, all right, where is the boundary at x equals what? X equals what is the boundary? 0. X equals 0 is my boundary. So I have to plot f of 0. How much is that? 0 plus 2, it's 2. Right there. Okay? Now, what kind of graph is this? Negative x plus 2. Is it a linear graph, quadratic? It's a linear graph. What's the slope? Is it going up, down? It's falling here with a slope of negative 1, right? So now, I know at this point you guys can graph any which way. If you want to just graph a line that's falling with a slope of negative 1, that looks like something like this, right? If you want to just do that, go ahead and just do that. If you want to say, you know what, let me pick another point and see what the value is there, then go ahead and do that. At negative 1, this is how much? 3. So we can do that as well. Okay, question? Oh, yes. Yeah, no, but what I messed up on is this. Yeah. So this here, initially, you remember how I got x equals, at x equals 0, y equals 2. Because it's less than and not less than or equal to, this has to be an open circle. Okay, you see this number? Right, this defines my regions, right? Where is the region being split? At 0. That's that red line. So the first thing you do is you plug that value of x into that equation. You get 2, you plot the point.
But it's less than 0.
It doesn't matter, because the less than part tells you that later the graph is going to be to the left. Okay? Okay, other questions? Okay, now I'm going to graph the other one. What color should I use for that one? Let's see. Okay, let's do black. This one. Again, what's the boundary? 0. F of 0 is 2 again. Okay? So it's on top of that circle. If one is open and one is closed and they're on top of each other, just close the circle. Fill it in.
If one is open and one is closed, fill it in.
Yeah, and they lie on top of each other, just fill it in. Now, what am I graphing there? X squared plus 2. What is that? It's a parabola, all right? Again, it's up to you how you want to graph the parabola. Let's pick another point. Why not? At x equals 1, how much is it? 3, right? And so it's going to be a parabola going up like that. Yeah. Yeah. Okay?
They overlap on the left side also.
Yeah, they will only overlap on one point, at one point.
Don't they overlap on the left?
No. This is only, yeah. And then, you can erase this. I don't want to get too in the habit of drawing that. It's just for us to guide us because I don't want it to be confused with vertical asymptotes. Okay, let's solve this problem. A cell phone company offers you the following plan. You know what? I think this problem is getting outdated because this is how things were a while. Okay, way back when, you couldn't just use your cell phone whenever you wanted. You only had a certain number of minutes that you could use your cell phone, right? Over the weekend, it may have been like unlimited, right? So like a lot of times we would tell our friends, hey, you know what? Call me back. Like if it was a Friday, hey, call me back at 7 because I have minutes. I'm running out of minutes. Like this is such an old problem now. Like during the week, we would only have, let's say, 500 minutes of talk time. And so if we were at like 495 minutes and our friend called and was like, hey, how you doing? You're like, you know what? I don't have time for this right now. I only got 5 minutes. Call me when somebody's at the hospital. Okay?
You don't want to talk to somebody?
Yeah.
Could you be like, oh, I'm sorry, I only have 5 minutes.
Yeah, I'm out of minutes, man. I'm sorry. I can't talk to you. Huh? Yeah. You wouldn't pick up. You'd be like, sorry, call me Friday, 7 p.m. Huh? Both. Okay. So there were like these complicated plans. Here's how the plans worked. $80 a month. You got 1,500 anytime voice minutes. Okay? And then free night, weekends, and unlimited texting. So once you were done with the 1,500 minutes, each additional minute now costs 40 cents a minute. Okay? So we can actually write this using a piecewise function. So as long as, okay, so here it is. So T is the number of minutes you speak, right? As long as T is between 0 and 150, you get charged $80. So as long as T is between 0 and 50, you get charged $80. Now, let's think about this for a minute. Suppose you spoke for 1,505 minutes. How much are you going to pay? You're going to pay the initial 80 plus how many minutes did you go over? 5 times 0.4. How did Sivan get the 5? What did she do? She subtracted T minus 1,500. So look, that's what this says. You're going to pay the 80 and then T minus 1,500 times 0.40. That's if you spoke over 1,500 minutes. Okay? Now, so that's the piecewise function. Now this is telling you what is C of 754. C of 754, huh? Right? So, but what is C? C is the cost. C of 700, so if you spoke 754 minutes, how much are you paying? $80. And it says state the significance. So what does this stand for? Right, so basically this is the cost if you used 754 minutes. So here is another question for you, part B. How much would C of 2,000 be? What would you do? Where would you plug it in? The bottom, exactly. 80 plus 0.4 times 2,000 minus 1,500, and it turns out to be $280 for that month, man. Okay? That's a lot of money. You have no idea how costly it was. Okay. All right, let's do this. Here's another piecewise function. Can we find f of negative 2? Where do I plug it in? F of negative 2. Look at these regions. Where does negative 2 fit in? The first one. So f of negative 2 is negative 2, 2. F of 3, where does that fall? The last one. And what's the y value for that one? 1. Always just 1. All right? Okay, now I will stop here. And that will take like 10 minutes to do next time.